Okay. Are we still remembering the continuous method? So, are you still remembering the continuous method? Can you tell if it happens to her? Good. So, so we just have to now have the second part, which is algebraic methods. According to the question, maybe we should write what are the requirements for X and what are the requirements for Y. For Y, we said X is what? X is what? How many? Or else we should start from the question itself. What does the question tell us? We should start from the question. Loveness, the question itself.
The whole question.
We are saying A, B, C, X, and Y. Okay? We should write those. Maybe we should start from there. Okay, we are saying A, B, C, X, and Y, is it? X and Y, we were saying what are they? Department cost centers, okay? While these are production. 3 are production. These are service centers. Okay? So we are saying A is how much? 40. B, 42. C, 45. X, 40. Y, 42. Okay? And we are told that X, when it is given to Y, I mean to A, is how, what percentage? We're talking of X. Now giving, when it comes to allocation, what percentage does he give to A? 20%. B, 30%. C, 10%. X, does it give itself? No. Y, 40%. Then we're saying X, when it is given to the department's production cost centers, what percentage is he giving to A? 30%. The same with B, is it? Yes. Then C, 20. X, 20. Does he give to himself? No. So these are the figures that we have, and we are supposed to create an equation from there, simultaneous equation. What we're saying is that apart from this, or what A this has, Y will give 40% to X, isn't it? Ndikunena kuti X uyu ali ndi izizi ngakhale ali ndi izizi Saramira from each and every cost center. R and S from Y, isn't it? Yes, so we want to make a simultaneous equation out of that. That's why I'm explaining that for you to understand. And then we're saying Y has got 42, but he is supposed again to get from X. What percentage does Y get from X? 20%. So what we are saying is that X, when it comes to what he has to give A, that amount, B, that percentage, that percentage. But he doesn't give himself, he also gives to Y. So what we want to make a simultaneous equation is only based on X and Y, because Y and X are the ones that gives, isn't it? Yes. So we are going to make an equation. Can anyone try? But you have to explain when you have tried. Apart from X himself having how many? 40. He has X has got 40,000. But apart from the 40,000 he has, he also has to get from Y 20%. So we are going to add 20%. Zimene zimachitika nzoti timachita distribute izi zokha kuti zipite uko. Koma sopano tikufuna tipange simultaneous equation kuti tipezeso ngati mafigures amene tinapeza last time, but in a simultaneous equation way. What we are saying is that apart from what he has, X has, which is supposed to distribute to production centers, he is also given the amount percentage from Y, what we have written here. Y gives X 20%, isn't it? That's what I've written there, just for your explanation. Therefore, in a normal way, we can say X is equal to 40,000 plus, if we want to decimalize the percentage, it's 0.21. I did that deliberately for you to understand. Any questions before we go ahead? Any questions, please? Lavo, I want you to ask a question. Khadija, you don't have? No. Have you understood? If I ask you, you can explain to me. This one is going to come on an exam, whether you like it or not. Thank you. This one? Is it fun? Mike? But you can ask before we go ahead. We are saying X on his own, he has that is supposed to distribute. If we go to continuous method, you remember, we could finish the figure of X, but later on, because he has been given from Y, we could distribute the Y, the figure that was given to him by Y. Isn't it? Yes, that's what we're talking about. So we're saying X, that is the equation that he should have. Because this is a simple thing. It will be difficult for you. And those that are not attending, they will think as if in there. But it's in a body, they have not come. If you have met him outside, he said, come. He could not. So that's that. But what we want to explain here is that we should again understand how we make the simultaneous equation. How about the Y? Now, who can try Y? Y? Khadija, can you try the equation for Y?
It's 42,000 plus 40%.
Good. 42,000. We should add 40%. which is from x. Therefore, y is equal to 42,000 plus what? If we want to write like that,
0.4.
come again?
0.4.
0.4. If it's 40, divide by 100, we want to decimalize it. 0, 0. 10 into 4 point, isn't it? That's how we do it, isn't it? 10 into 40, if we add a 0 is what? Should it be with a 0 in front? 40%, should it be 0.04? Kanena nini unafunzira decimal points? Timamanga tena? Come again?
40 divided by 100.
It's 40 divided by 100. 0.4. Yes, it's just the same. When I say point something, it's just the same as 0.21. It's just the same. You get the point. But it can't be 0.04 or 0.02. If it's 0.02, it means the divisible number should be 1,000, isn't it? Yes. So we are saying, yes, it should be. If we don't care, we cannot put a 0 in front. Because a 0 is useless in front, isn't it? It's useless. But just for you to understand, we can put a 0. So we are saying it should be plus 0.4. What? 0.4 what?
X.
X. Because this represents the x that gives the y. This represents the 40 that is given to him. Any questions? Any questions? Pepa ndipo ndaenda basi kutoka paka ucheni hapo paka stage hapo, but I think because kusazorowera kuyenda ndizuwa, but it's fine. It's fine. So we are saying that those are the two equations that we have made so far. The simultaneous equation. So we should calculate. Who can come and calculate? So we are saying, what are our two main ones? The simultaneous equations that we have made are these. That and that one. These are the two equations that we can think about when we're talking about simultaneous. Who can come and calculate that? Tina kuzina tuma simultaneous equation of secondary school, isn't it? Michael, Lusungu, you remember that?
Yes.
Yeah?
Nothing ever seen that.
There's much time. Yes. How should we calculate? We are going to do it together. I want somebody to come and try. Don't look busy, because this one I want you to understand. This one doesn't take time when it comes to an exam than the continuous. But once you understand it, it's easy. Because normally they don't ask us to write both methods, but choose one. Who can come and try the two equations? Okay, let's do it together. Let me write here x is equal to 40,000 plus 0.21. X, y is equal to 42,000 plus 0.4x. So we are going to substitute wherever there is an x, we put a y if we want to start with the finding of y. If we want to start with an x, we are going to put where there is y, we are going to put the y. Isn't it? That's how we do it, isn't it? Yes. So we're going to say x is equal to 40,000 plus 0.2 brackets. This is the whole y, isn't it? Isn't it?
Yes.
So what is the y now? 42,000 plus 0.4x. It means now these are like terms whereby we can find x, isn't it? As easy as that. I don't know. So we are going to put them together according to what they are. X is equal to, let's continue now. We first multiply that into that, isn't it? Don't write. We have to first hear what is going on. 40,000 plus, that should multiply that, isn't it? Yeah.
Yeah.
It looks as if I'm only the only one that is in class. 0.2 times 42,000. Do it on what that means?
8,400.
We are saying plus 8,400. 0.2 times the point x, 0.4x. Does it, is easy to use that? We have to come and use whether I get it or not.
0.08.
Come again.
0.08.
Plus 0.08x. Like that, is it? So we want to find x still, isn't it? Yes. So we continue to say x is equal to that plus that, isn't it? Yes. Therefore, it's how much? $48,400, isn't it? 40,000 divided 8 plus 8,400. Then we are going to add what? 0.08x. So like terms have to be together, isn't it?
Yes.
Where should we take the 8x? 0.08x? To the x side. So we're saying x. What is it going to carry if it goes this other side? Negative. Therefore, it's going to be minus 0.08x, which is equal to
48,500.
Therefore, what are we going to do now? If this less that, what is the figure that you are supposed to put here? X is what? Here. Now, so
0.9.
we are saying 0.92. What? X is equal to 48,400. Therefore, x, we divide both sides. That's the rule that we all know when it comes to a simultaneous equation. Therefore, we divide by 0.92 both sides. 0.92. How do we find x? What is it? Yes? Here? From there? Good. We're saying this is x minus 0.8x. It should be a different figure, is it? Good. What should it be? Come again?
0.92.
No. What should you think should it be? Because this is a very good argument.
I'm confused there.
Okay. Come again?
Timothy.
Yes, Timothy. Timothy is the one that said this. Can you explain to him why we have come to him?
Because just saying x is the
Someone says saying 1x. So
Good.
x is
It's the same as saying 1. It's the same as saying 1. But the one that is subtracting is a what? Is a decimal point. Isn't it? Isn't it?
Yes.
Yes. Therefore, if it's a decimal point, it means this carries a divisible number of what? 100. If it carries a divisible number of 100, therefore this should be equal up to that, meaning 1. Something to do. It's difficult to understand when you are not there. Can you explain why you have found 90.92?
Okay.
Yes.
There is write them together. X minus 0.08. So x is same as 1. So 1 minus 0.08.
Rusungu, what you are saying is that x is just the same as 1, and we are supposed to subtract a number that is 0.08. You get the point? So if it's 0.08, how do we find the figure? Normally, when we are talking about 2 decimal points, it means we are talking of a divisible number of 100. So this, if it were in percentage, this one is 80%. If it was 80%, it means it would have been 0.8. I don't know whether I understand it. So why we have taken to 92? Because if we say 0.08, it means it's 001, which is 100. That's why we have subtracted 8 from 100, making to 92. That's what Timothy did. So when we are talking about the simultaneous equations, we always have to put the like terms together. Then we did that. Maybe I should start there. We had that. We multiplied that by that. This is point, mind you. That's why it was a very small figure. That is point, mind you. If you multiply a point and a point, there should be a 0 in between the figure that you're going to find. So this is what we have found. And then we have said that is that. We are taking this one. If it goes to the other side of the equation, it's going to carry the minus sign because it has a plus sign. So we have said that x minus that is equal to 48 after adding that and that. So we are saying 0.092 divided both sides for us to find x. What is the answer?
52.
It's 34.10.
52.
608.
608.
Point.
Point.
6957.
Less 0.6 or already it's what? To the nearest is what? 9. So this is the value of what? X. Is it difficult?
No.
It's just unfortunate that we are not going to meet after end of semester exams. I would have said, look what Karivote who was shining. Very good if you can shine like that. Great. So now who can come and finish the value of y now? Because you were refusing to come in front to find the value of x, but now who can come and find the value of y? No. That's your space. Because your friends.
Okay, this is equation 1. This is equation 2.
No, we have already done that, man. You are supposed to find the value of y. That's your reason to be here. We have already found that is the first equation, that's the second. We want you to find the value of y. That's all. You should be telling your friends, not just write.
Okay, guys. This is x. So we are going to substitute x to equation 2. I think you first, when you do the subject formula, you do in this way. So you need to substitute it in version 2. If you make subject formula x in that version, you can go.
We are not, my dear. Subject of a few formula, we're talking of x. Subject of a formula is x. Why?
So we are substituting x in this version.
That's all. Not subject of the formula. Why should you talk of subject of the formula then? Can you vote?
X is 5, 2, 6,
9.
0.4 times 5, 2.
Huh?
0.4 times this now. 22,609.
It's 21,000.
21,000 043.6
0.4.
3.4.
3. What year?
I need
0.6.
6.
So we can just do this here. 4.
1K44.
Add what? These two.
63,000.
Yeah.
60,000.
60,000. 0.
4.
4. That's our.
So these are our figures that y has and x has. So what we are supposed to do now is we're supposed to find, as we're doing the continuous method that we have. So we're supposed to draw a schedule. What I'm saying is that on an exam, this one will come. If it will come, you can choose which method you can want. If it happens to say that you should choose one method, you can choose either continuous or this one. This one is cheap. You don't take time than the continuous. First phase, second phase, and so on. So I'm going to lab, and then we should put in the
So ma'am, before you sorry, we are late, but may you please delete the first, how we introduce the equations?
Where were you when I was introducing? Didn't I call you outside there?
Yeah, my friend is sick as me, so I was it.
Hey, but imagine, love, didn't I explain how we found the equations? Because you were late. I said this question is going to come. Munali and Kawili, you know. I mean, a number. We are saying I introduced them on this one. These are the figures that we are given by the question. A has got 40. B has got 42. C has got 45. X has got 40 and Y has got 42. But in the question, they're telling us that X gives the A 20%, B 30%, and so on. But he doesn't give himself. He also gives Y 40%. So we have the second service center that is Y. He gives A 30, B 30, C 20, X 20, but himself doesn't. But the secret is that service centers are the ones that were supposed to distribute to production centers A, B, and C. Therefore, we should make an equation for only X and Y because we are going to distribute them to production centers so that we should find how much we should distribute afterwards to have found their values. So we say that as the X, which is this one, X, he also has that amount, isn't it? Can you vote now?
Yeah.
He has 40, isn't it?
Yes.
40,000. This is the amount that has been allocated to it as a department.
Yes.
But apart from that, he also gets from Y how much? 40%. So therefore, we are saying when we want to find X, we should also add the value that he gets from what? Y. But when we are talking of equation, we cannot write 40%. We should decimalize it and find what it is. Then we said it should be X, it equals 40,000 plus plus 0.4. Because it's 40%. If it was 4%, it would have been 0.04. But we're talking of 40%. Therefore, because this one is not an x, this one is a y.
Okay.
You get the point?
Yes.
Yes. So this is the first equation. In fact, it's not 40. It should be 40 gives y, x gives 40 to y, but the y gets 20 to x, isn't it? Therefore, it should be 20. So this should be 2y. That's why we came to that as a first equation. You came here and shined that this is first equation as if you knew. I thought you knew. That is good. No, so this is how we decide how to make an equation. Because we only distribute service centers, which is x and y. We should only write the equations for x and y. We base on how much x has, which has been allocated to it, and the percentage which is supposed to be given to it by y. We add. If you remember continuous method, we could say, we could finish the value of x, but because he has taken from y, we could again redistribute from that value that was given by y to x. So this is exactly what we are doing. So now we want to make a schedule. Should I now?
Yes.
Is it fine?
Yes.
Timothy? Good. So I'm going to lab so that we should continue with the shared schedule, because you can't just write this and this, then you expect a 20%. I will give you.
80.
No. A schedule is the one. Costing we base on schedules. It will be 10. It will be 10. So please, I'm going to lab, but I shouldn't lab in my head. Mukukumukira?
Yeah.
Musongo, is it fine?
Yeah.
Even if I lab?
Yeah.
Good. Khadija? Good.
So, madam,
Yeah.
in exams, you're going to bring this sum and the sum that we did the previous. Is
Come
it
again?
not? Is it not the same like? Yeah.
Nanga kusaidia.
Tamu
Alikuza example hii.
Okay. To first I put it. As a first, Mr. Last week you just what you really that.
The most different method of solving it. Simultaneously, continuous.
Oh.
Simultaneous equation. Simultaneous methods. Method.
Okay.
Yeah.
Last week,
That's it.
it is the same example, but they have two methods.
Yeah.
That's why I was saying, becoming early in class, mainly when we are towards exams. Because sometimes the lecturer stresses on a point that is very important that you should take note. Okay? That's why I was angry with Garifuta. To say, you were not here. I explained, but you weren't here. Okay? I even called him, come, we're supposed to be in class. You went. So these are some of the things that you have to be very careful. It's better because it's a university. But at a secondary school, I would have said, Kalivute, don't come in my class. You get the point? So please, school is yours, it's not ours. We just want you to assist you to be there. Okay?
Yeah.
So why am I saying all this? Because it may come, it may not, but normally it comes for you to choose one method. You can either choose the continuous distribution or this one. If you are serious in the book, it is there, only that no methods are there. You just have to go back to what we were writing and then see if you can find the answers. But sometimes you cannot. If you miss it on the subtraction of x there, if you miss it, you miss it.
Last
get
week
it?
I did.
Come again?
Last week I did. I went back.
Good.
Luwazani.
Good. That's what is wanted, not just sitting. Okay, so we're saying we still have that same schedule that we had last time. What was the first column? Item. The second column was what? Basis of apportionment. Basis. I will just write that. But we nimalize. Then the third one,
Total.
total. The other one, ABC, B. Yes. A, B, C,
X, Y.
X, Y.
X, Y.
So this is our schedule that we are having. Where we are going to have allotted overheads. Allotted overheads. Allotted overheads. What was the A? 40,000. B? 42,000. C? 45,000. X? 40,000. That is what we have been allocated or allotted. 40 and then 42. So this is the first line that we are having. And what is the basis that has been done? We don't know because we're just given. Okay? We don't know the basis that they're based on because we're just given the figures. So now we're going to reapportion. Reapportionment. Reapportionment, we are going to say now X and Y. Because they're the ones that were supposed to distribute, isn't it? Yes. Now, what basis are we going to base on? We're going to base on percentage. Let me just put that. Percentage. Because we're given the percentages that we should be basing on, isn't it? Yes. That's our basis. So we have X, and when we have X, what should we do? We have the only one phase. We should not forget writing first phase. Tipanga kamozi basi. Sikawili kabisa. X, whereby maybe we should write totals first for this. What did we say last time? 209,000. So first phase, what are we saying? We're saying that when we're talking about X, how much should we, the figure that we have for X is what?
40,000.
Oh,
No.
again, he was given other figures from Y that he calculated to find out the simultaneous equation.
2,609.
Basi kutoka basi niende kumununga ukapile basi niende swa ya diesel acha imerekuja I think guledi mwe government dissolved. We have new figures which we are having for X, isn't it?
Yes.
What is the new figure?
X is 52,000.
52,000. So we are saying on X, on the reapportionment, we are having 52. What? 52,000?
609.
609. We should put it in brackets to show that we are distributing it. You get the point? Then we are going to be saying again, x gives a how much?
20%.
Huh?
X is 20%.
Come again?
20%.
20%, this is x, this is y. 20% of that is what? Come again?
10,000.
10,000.
521.
10,520.
21.8, which is 2.
10, 5 to 2. Good. Then B, no, where to B? 10, 5 to 2. B, what is it? X gives 30%. What is 30% of that?
15,000.
50,000.
780.
783 to the nearest, that is?
It was 0.7, then it's 3.
It's 9.
Oh, yeah, 9. 15,000.
Wait.
15,000 what?
700.
783.
783. You went
80. 783. Like that.
Yes.
Good. Then the 10% to C, that's X gives
5,261.
5,200 and what?
61.
61. Then to Y, X
21,043.
21,000 and what?
44.
And 44 to the nearest, that is it?
Yeah.
Yes.
Yes. So we're saying that is the end of the distribution for X. And then we go to Y. We go to Y. Y, the good part is that that's when you can prove that your answer is correct. If you add that and that, it's the same answer that we found when the value of Y when we had calculated. That can Vute found, isn't it?
Yes.
Yes, so we're saying, what is the figure that we are going to distribute for Y?
So 63
Mhm.
and 44.
And 44. We put it in brackets to show that that is the distribution that I'm making for Y. And you don't forget to write first phase for Y. So we're saying Y gives a 30%. What is 30% of 6344?
18,980.
18,913. So it's the same with B, isn't it? So the same with B, isn't it?
Yes.
Yes. So we're saying 18,913. Why? Because it's also 30%. How about 20% of
12,609.
come again?
12,000.
Come again?
12,000.
4, 1, 2,000.
609.
609.
Yeah.
Good. This one the same, isn't it?
Yeah.
Yes.
4, 6, 0.
9.
You get the point? Good. So that and that cancels to 0, isn't it? Yes. If you add that and that equals to that 0, 0, isn't it? So we're saying this is 0, this one is 0. That is plus, that is plus, this is minus. Therefore it's 0, isn't it? So just add that, and the figures we find here are the ones the same as we found in the continuous distribution. Any questions?
Wow.
Any questions, please?
Okay. That means this number, that A, B, C.
Let's
D.
add together. Let's find that plus that plus that. That plus that plus that. And that plus that plus that. So there are 0. And then you find the answer. The answers, if you add the answer here, the answer here, the answer here, should be the same as 209. Because we are just redistributed.
The first one is 69,435.
59.
69.
Oh, good. 69.
435.
435. The second one.
Just
Michael? $70.
What's that number? Is that 18,000?
18,913.
Oh, 76,696.
96.
Yeah.
How about here? You see? Michael, you have been quiet for long. Panga tikuveka utayankhula kwina. The next row is for you, my dear. We add 45, 52. Is it 52, Ted?
5261.
And then 12609.
62,807.
62,807.
807.
70. Good. If you see the figures, are they the same with the ones that we did with the continuous allotment or distribution?
Yes.
Yeah.
Are they the same?
Yes.
Good. That is to prove yourself that you have done it for the algebraic method or simultaneous equation. Is it? Ungopanga kamozi for this simultaneous. Which one is cheap?
This one.
This one is cheap. So far, ukangopanga pa equation paja bwino bwino. This one is cheap. Within 10 minutes wakulisa, mina 5 minutes wamaliza. Then you go to difficult ones. Zimene kuona kuti because continuous will be first, second, and so on and so up to the time it's 0. But here just do it once, you forget. Love, is it fine? Khadija? Good. Good. Any questions before we go to revision a bit? I know time is already at an instance.
No question is good.
We should go to revision. Good. What topics did we cover so that we should revise? Sorry, I'm rapping. Maybe before as I'm rapping, please. ABC are what centers or departments? ABC. What are they?
Departments.
Yes, they're departments. Even X and Y are departments. But what are they?
Okay, X and Y is the service departments, while ABC are production.
Yes, are production departments. ABC. X and Y are service departments. Can you give an example of a service department here at Lidongwe University? Khadija, no, Kalifute. Give space to your friends, please. They also are here in class. An example of a service center or department here at Lidongwe University. Come again. Who can assist Khadija? Right. Thank you so much. Okay. So what does it mean when we're talking of service departments? Love. What do we mean when we're talking about service departments? Linda?
I think everyone can.
Yes, goes to that department. It assists everybody. Containing right, human resource of this. You can go there. Even accounts, you go there to pay fees. I also go there to take my salary, isn't it? Yes, everybody goes there. So these are some of the examples of service departments. Okay. So what are the topics that we should now look into? What we have learned? Or else those that you think are very difficult to you that you want to understand them?
Madam, how about we just use all we have written?
Good. Let's try that. I was against time, but Timothy says, no. We should do all of them.
Yeah,
Great.
he's right.
Yes, that one. We are going to do it in class, but he finds time. The week that you are given for free, this period is going to have a class next week. Sit down, discuss. Okay? For my subject. For you to make it. And amazunguzika tumayeso koma mukakhala pasi mukachita discuss, believe it or not, and you really see that they know what they are doing. And amazunguzika the same sample imene tawerenga apapo kubwera pamayeso exactly the same figures, somebody is confused. But when you sit down and discuss, you're going to find it easier. Okay, so what are the topics that we have covered so far?
Classification of overheads.
Classification of what?
Overheads.
Of overhead. Good. We have started from back where we are. Everybody is going to give in a topic that we have covered so far.
Inventory control system.
Inventory.
Accounting.
Come again?
Accounting for and control frame.
Of what? Control what?
Labor.
Labor. Topics that we have covered so far. Labor turnover, it's part of that.
Rules of cost and management.
Laws of cost and management.
Elements of costs.
Come again?
Elements of costs.
Elements of cost.
Accounting for and control of materials.
For what?
Accounting for and control of materials.
Material. Good. Topics that we have covered so that we should go through, go over, so that we can understand them better. Others understand them better, but the other one maybe somebody cannot understand them better. But you can always, how about because of material, it's that. And the material, what should we also think about? Come again?
Other overheads. Direct and indirect.
Okay, direct and indirect. The other one, very important. Maybe it's here, maybe. Let's see. Come again? Oh, wait a minute.
What about elimination?
Remuneration. If we think we are over, then we should start going over, right? So that we should know. Base.
Okay.
Financial accounting and management accounting.
Coding.
Coding.
Accounting for and control of overheads.
Classification of overheads. It's there.
Okay.
Control. Accounting.
Mixed cost.
Okay, mixed cost.
Cost classification methods.
Cost classification.
Accounting for elements of labor costs.
Labor. As we're going to be going over, you can remember another topic, and then we should again revisit it, because time is always against us. At the end of, towards the end of the period, we have to give each other maybe potential areas that can come in case. So, let's go over that. This is the something that we have learned. In fact, it's just a skeleton of it, but not the whole of it. But these are some of the things that we have covered so far. We start with the first one, financial and management accounting. What is financial accounting? And what is management accounting? You can choose which one to talk about. Because sometimes a question comes, can you differentiate between them? Michael, you can choose one of them, one of the accounting that you can remember, if you can. And then Khadija talks about this other one. Financial,
Management accounting.
yes.
It involves planning, budgeting, and controlling activities inside the organization.
Very good. Great. We are talking about the management accounting that only concerns the organization. Then Michael, now go to the financial accounting.
Financial accounting. This reports, it reports
You should speak up because our friends out there, they want to understand us also.
financial accounting reports to, it also reports to the outsiders to tell, hey,
Yes, we are talking about financial accounting where it involves outside organizations, shareholders, government, even our subsidiaries or sister companies. So when we're talking of financial, we are talking of something that is reported, the accounting is reported outside the organization. While when we're talking about management, we're talking about inside. Example, Rinongo University can not say about, let's say, a salary of a laborer outside. Maybe outside when it comes to tax.